Arcs are portions of the circumference of a circle. To draw an arc, you specify the arc's starting angle and ending angle, measured in radians. Um, the arc is said to sweep from its starting angle to its ending angle. Figure 14.4, which we'll look at in a moment. Um, the arc at the left of the figure sweeps counterclockwise from 0 radians to pi divided by 2 radians, resulting in an arc that sweeps 3/4 of the circumference of the circle. The arc at the right figure sweeps clockwise from 0 radians to pi divided by 2 radians. So this gives you an idea of an arc, how it works. Shows how arcs and circles using arc method. The begin path starts with the path. Next, the arc method draws the circle using 5 arguments. First 2 arguments represent the x and y coordinates of the center of the circle rather. In this case, 35, 50. The next argument is the radius of the circle. The fourth and fifth arguments are the arc's starting and ending angles in radians. In this case, the ending angle is pi times 2. Constant math.pi is a part of JavaScript representation of the mathematical constant pi. The ratio of the circle's circumference to its diameter. 2 pi radians represents a 360-degree arc. Pi radians is 180 degrees, and pi divided by 2 is 90. To draw the circle to the canvas, we specify a fill style of medium slate blue, then draw the circle using fill method. Okay, so in this example here, you can see they begin the path. So 3550 is the center, the xy coordinate for the center of the circle, and then how we're going to draw it. So it's going to be a positive angle, and the circumference is pi times 2, which is 360 degrees. Medium slate blue is a specific color. And so it looks like we're going to be drawing several circles here with different colors. Half circle, which is just pi, and then going counterclockwise. Okay, so you can see what we've got here. Full circle in blue. Got the arc, semicircle, and 3/4 of a circle. Is that the CD that came with the book, Andrew? Okay, drawing arcs and circles. We then draw a black arc that sweeps clockwise. Using the arc method, we draw an arc with a center of 110.50, a radius of 30, a starting angle of 0, and an ending angle of math.pi, which is 180 degrees, which would be a half circle. The sixth argument is optional, specifies the direction of the arc's path is drawn. By default, the sixth argument is false, indicating the arc is drawn clockwise. True means counterclockwise. Okay. Yeah, let me know, Andrea, because I downloaded that. I went to their website and downloaded zip files from both the student and teacher resource areas, and I could not find these examples. Yeah, if you email me the zip, I'll put it on my website so everyone can download it. Because I could not find it. Okay, drawing arcs and circles. Next we draw a filled red semicircle counterclockwise so this sweeps upward. To draw the arc counterclockwise, we use the sixth argument is true. Finally, we draw a dark orange 270-degree clockwise arc. Since we do not include the optional sixth argument, it defaults to false, drawing the arc clockwise. Alright, thanks, Andrea. Shadows. In the next example, we had shadows to the filled rectangles. We start by specifying the shadow blur attribute. And this may be actually the example I showed you with this first example. I'm wondering. Because the first example that I have on my website is a shadow attribute, so I wonder if this is it. And I just didn't have the first two examples. Let me see. Hold on for a second. I got that one. Okay, so the example I showed you is not quite the same, but it actually does a lot of the same thing. So, okay. So it gets the context, sets the blur to 10, the offset of 1515, so it's actually going to have more of a blur than the one I showed you, and then the color of blue, and the fill style of cayenne, and it fills the rect. Alright, so see what you get here. You get two, the shadow effect, that way and that way. And in my example that I had from their website, somewhat similar. It actually shadowed the letters. For the second rectangle, we create a shadow that shifts above and to the left of the rectangle. Notice this shadow blur is 20. The effect is a shadow on, which the edges appear more blurred than the shadow on the first rectangle. Next, we specify the shadow offset x at value of negative 20, which is a negative shadow effect, moves the shadow to the left of the rectangle. Then we specify the shadow off-white attribute of negative 20, which moves the shadow up. Shows 14.7 demonstrates how to draw a rounded rectangle using lines to draw the straight lines and the quadratic curves to draw the rounded corners. Quadratic curves have a starting point, an ending point, and a single point of inflection. Quadratic curve 2 method uses 4 arguments. First are the x and the y, or the coordinates of the control point, the point of the curve's inflection. The third and fourth arguments, x and y, are the coordinate of the ending point. The starting point is the last subpath destination specified using the move to, or line to. So, for example, context.move to, context.quadratic curve to 25, 5. The curve starts at 100, curves at 25, 5, and ends at 95, 50. So, and that's this example here. And it's creating a couple of them, it looks like. And then you get something like that. The yellow internal. You can see a little bit of a curve instead of a cornered edge. Those little curves there created by, in this particular case, the 5, 5. So a little bit, puts a bit of a curve on it. Alright, and Bezier curves have a starting point and ending point, two control points through which the curve passes. These can be used to draw a line curves with 1 or 2 points of inflection, depending on the coordinates of the 4 points. For example, you might use a Bezier curve to draw complex shapes with S-shaped curves. The Bezier curve 2 method uses 6 arguments. First 2 are the inflection, third and fourth are second control points. Finally, the fifth and sixth coordinates are the ending point. The ending point is the last subpath destination specifying using either, again, move to or line to. And the next example shows how that works. Okay. Got move to, got the curve, line width of 10, stroke style red. So you get something like that. It's interesting. I've not worked with this Bezier before. It's something new to me. Okay, linear gradients. Linear gradients. I do have an example of a linear gradient. Fills 3 separate different canvases, and the linear gradients, which we'll look at in a moment. The example I have is this one here. We'll look at what they have. On the canvas, we draw a vertical gradient. We use great linear gradient method. First 2 arguments are again of the x and y coordinate. And the last 2 are the x, y coordinates of the end. Start and end have the same x coordinates, but different y coordinates. The start of the gradient is a point at the top canvas directly above the point at the end of the gradient at the bottom. This creates vertical line gradients that starts at the top and changes as the gradient moves to the bottom. Okay, so in this particular example, which is a little different than mine, gets the context, creates the gradient, 0, 0 to 0, 200, puts in colors starting at 0 white, and then 0.5 would be 50%, changes to light blue, and then the remainder navy. Fills the style is gradient, and so it starts at white and it ends with navy, and it hits light blue by the midpoint. It's got a couple of other gradients doing similar things, 0.5, white, yellow, orange. And then going from white, plum, and purple. And this is what you see. This is what they've got. Now the example I have is this one right here. We'll look at this code. It's a little different, and it has a gradient that starts at 0, 0 and goes to 350, 500. So it goes from here all the way down to here, ultimately ending with violet, and in a particular corner. So we see we start with orange, which is this color here. Then at the 34% mark, we switch to yellow. At the 51% mark, we switch to green. And then yellow, then blue, and indigo, and then finally violet. And then we display it. and we get those nice sort of psychedelic colors there. Any questions so far on these examples? And there are some other examples as well that we can look at. We use add color stop method to add 3 different colors. Each color type has a positive value 0 of the gradient and 1 the end of the gradient for which to place it in. The fill style method specifies a gradient, and then the fill rect method draws the gradient on the canvas. On the second canvas, we draw a horizontal gradient, which we created, and we just do that by specifying the numbers where the 0, 0, or the starting point, and then the gradient endpoint is 200, 0, so the y is the same in both cases, so that makes it a horizontal gradient. And then we create a diagonal one, which is the example I showed you as well, by starting at an xy coordinate and then having the last 2 coordinates be completely different. And that creates a diagonal line. Okay, radial gradients on the canvas are comprised of 2 circles, an inner circle and an outer circle. We use create radial gradient method, whose first 3 arguments are the xy coordinates and the radius of the gradient, and whose last 3 arguments are the xy coordinates and the radius of the end circle. The first radial gradient is has concentric circles. They have the same x and y coordinates, but each has a different radius, creating a radial gradient that starts in a common center and changes as it moves outward. On the second canvas, the start and end circles have different x and y coordinates alternating the fact these are not concentric circles. The start circle of the gradient is near the bottom left and the canvas, and the end circle is centered on the canvas. This creates a radial gradient that starts near the bottom left of the canvas and changes its move to the right. Let's see here. I have an example as well, but it's probably not exactly the same as the example they have, but we'll take a look at it. Again, it gets a reference to the canvas. Creates a radial gradient, and at those specified coordinates, and then adds a bunch of colors for particular points along the way. And then it looks like it creates another one, red, orange, yellow, again, white, going from red down to white at certain points along the way. And it creates a circle within a circle. Now, if I look at my example, Where are we at? That's the one I have. Let me see. Let me sort of change these examples a little bit. Okay, that's nothing. Take a look at this one here, which I think is the one I wanted to look at anyway. So my one, we can look at the source, and we'll just see that it's a little bit different. One of the things that it's doing differently here is that it's not a full circle. It's not a circle within a circle. But it does some similar things there. And you can see that the starting and the end point are basically the same. And then we're adding different colors along the line. Lime, starting with lime, then going to yellow, then going to purple, and there's all kinds of fades in. So some nice cool stuff you can do there. Let me see if this example is fixed now. Interesting. It doesn't seem to do that one. I wonder if that's a compatibility issue. Let me see. Maybe it is. Probably should be just doing these things on Chrome anyway. Oh, there we go. That's the other example I have. That didn't work on IE9, so, and you're right, Chrome seems to be pretty compatible. That's another example of drawing a linear gradient and going to different lines. And putting in some different colors along the way. That's another pretty cool example. Alright. Okay, any questions so far? Let's just take a quick little break here, about 5 minutes or so, and then we'll pick it up with images right after that break.